It's been an hour 30. So to give you a sense of how, yeah, you need to be fast with this. You're not given a lot of time. Nowhere near as much time as I would have hoped. Okay, let's see how fast we can do question 2. Because question 2, honestly, I think the other person was right. It honestly might even be easier than the transients questions. Because transients questions is a lot of remembering. Oh no, we have to do Cramer's rule. It's going to take a while. So let's just copy down the circuit. This is plus minus. At 12 volts at 45 degrees phasor. We're going to move that. Yeah, so we're going to, there's another voltage source here. Plus or minus 6 with a negative 30 degree phasor. With an inductor across here. A resistor across here. An inductor across here. This is 2J. Another voltage drop here. Or another resistor. A capacitor. Yeah, they throw the whole book at you. Then across here, you have the resistor of 2 ohms. And then you have your dependent source coming up at 3ix. Jesus. And it asks, find the voltage at these two. Oh, I forgot. This is 4J. So this is V1. And this is V2. Where's IX? Oh, that's a great question. IX is going down here. So now we form the nodal equations. Remember, this is actually the exact same thing as this is the exact same thing as DC, really. So we have let's start with V1. Node 1. So remember the rule. So let's just start with a bunch of currents. We just assume the direction of our currents. So I'm going to assume like this. Again, well, not really again, but the actual direction you assume does not matter because you will get the exact same answer. The only difference, actually, there is no real difference. You will get the exact same answer. You could assume all of these currents are going away from a node. It will still work. I just find it easier to remember it like this. So, and this is our ground. So let's start with V1. Let's start with this current here. The rule is that you start from ground, or you start from your starting point, and you go up until you hit V1. And so it starts at a voltage of 0, so that's 0 volts. It goes across this this voltage source. It comes out of the positive end, so that's plus 12 with a phasor angle of 45 degrees. And then it ends at V1. And then you divide it by the resistance over the entire route you took, which is 3 ohms plus 2J. 3 plus 2J. So remember, with nodal analysis, it is from, so this is the from, minus the 2, and that's the 2. From ground, through the voltage source, to V1. Divide by the resistance. And now we do it again. The second source coming in. So plus, and again here, we're going to do from ground, plus, it goes across this voltage source out of the positive end, so that's plus 6 with a phasor of negative 30 degrees. and it ends at V1. And then we divide this by 4j. And now we do the parts that's coming out. So we do equals, and once again, from V1 minus 2 V2 divided by the resistance, 4 minus 10j. Question, answer, yes? No difference between 2j and j2, right? Yes, there's no difference. I don't like how they write j2. I write 2j. You will get the exact same answer. So that's node 1. We've covered all 3 of them here, going in and out. Now node 2. Node 2 is the exact same thing. Let's start with the ones going in, right? So the first one coming in, it comes from here. So it's V1 minus V2 over a resistance of 4 ohms minus 10j from minus 2. The second one coming in is here. So it comes from ground over 3ix into I2. Now, this is we actually measure this in current, not in voltage divided by resistance. So which is current. So we just do 3ix. Right? Because that's the current flowing in. Is equal to, and now the part's coming out. This is V2 from minus 2 ground divided by the resistance, 2 ohms. So that's V2 divided by 0. Now, this here, remember it's V divided by R, this is current. So, this is Ix. So this entire thing is Ix. Question. Just typically for nodal and mesh questions, we don't need to convert anything at the start, right? Usually no, but you should be prepared to. The equation is really simple, right? So all it is capacitance is 1 over JWC, and the inductance is 1 over the reactivity capacitance is 1 over JWC, and reactivity that is JWL. That's it. So this here is Ix. So we can actually just replace Ix with this equation. V2 over 2. Isn't it negative J1 over... It is the same. That's the same thing. So what do you call it? 1 over J is equal to negative J. So now we can so we've actually done part 1 down. 6 marks. Simplify the equation. So let's start with node 1. So I like to, you can do it however you want. You're going to get the same answer. It's algebra, right? All roads lead to Rome. The way that I like to do it is you break it out. First of all, let's get rid of these zeros. Is you split it up, and then you collect like terms. So 12 with a degree of 45 over 3 plus 2j minus V1 over 3 plus 2j plus 6 with a phasor of negative 30 degrees over 4j. Who did what shit? Minus V1 over 4j. Would someone do a soundboard? No, I disabled my soundboard because people kept on doing that. That's wild. If I don't know who did it, but please don't do that because you're just annoying people. This is node 1. So we split it up into these terms. And now we move the constants to one side and all of the ones with voltages in them to the other side. So what we're going to get is 1 over negative 1 over 3 plus 2j v1. So this one here. Minus 1 over 4j. Did he do it again? Minus 1 over 4j. This one here. Minus 1 over 4 minus 10j v1. This one here. Plus 1 over 4 minus 10j v2. Oh, I see. Is equal to. And now we move these to the other side. I'm circling these because I have an insane habit of skipping over terms. And if you find that you are in the same situation, do this. Just circle the stuff that you've done. So, here's our equation. And now we collect terms. So negative 1 over 3 plus 2j minus 1 over 4j minus 1 over 4 minus 10j v1 plus 1 over 4 minus 10j v2 is equal to, I'm going to save all of the annoyance of calculating that out. That's 4.1 with a phasor angle of 171 degrees. So, in case you didn't know, you can literally just put these numbers in your calculator. If you have the FX991ES, you can do phasors, you can do rect format, all that fun stuff. Read your manual. Can you show how to input it into the calculator? As a matter of fact, I can. Okay, so I accidentally stopped the recording there, and I did not notice at all until the entire question is done. So I'm going to run through the question again, just to show you how it's solved. I'm doing this after the fact, so there's no one else to answer or anything. Sorry. So first of all, just a note. The calculation there was wrong. This is a correct answer, not 4.1 with the phase angle of 171. So, I'm mainly just going to look over what I already did. 1 second. Okay, so let's collect these terms together. So go in your calculator and put in negative 1 over 3 plus 2i minus 1 over 4i minus 1 over 4 minus 10i. And we'll put that into polar format. So you get 0.414 with a phase angle of 130 degrees, V1, plus, and we're just going to put this in phasor form too. You don't really, you can mix and match how you want, but I feel like usually it's better just put into one form. That's just my opinion. You will get the exact same answer with a phase angle of 68 degrees. V2 is equal to 2.60 with a phase angle of 165.6 degrees. So now let's simplify node 2. So let's go up and take this here. Let's move that, erase that, and erase that 0, because minus 0 is equal to 0. You can get rid of minus 0. And so we just simplified just as we did there. The first thing you do, you split. Always split is your first thing. So 4 minus 10j v1 minus 1 over 4 minus 10j v2 plus 3 over 2 v2 minus 1 over 2 V2. And we'll bring everything with a voltage on the left side. Only constants go on the right side. Collect like terms. 1 over 4 minus 10J. Let's scratch that out. Minus, that's actually it. So V1. I scratch it out because I'm very prone to accidentally miscopying something down. So if you don't have a problem with that, then don't do it. But you need to find ways to mitigate mistakes, silly mistakes, because you will make them, or at least I do. Anyway, you collect. V2 is equal to 0. And now you calculate. So that's 1 over 4 minus 10I. Let's put that into polar format. That's 0.093 with a phasor angle of 68 degrees. Plus, this here is negative 1 over 4 minus 10I plus 3 over 2 minus 1 over 2. Put that into polar format. You get 0.97 with a phasor angle of negative 5.10 degrees. V2 is equal to 0. Now we have our nodes simplified. Let's pull this down here and pull this down here. And now we're going to turn it into matrix form. So first of all, let's just scratch out what we've already done. So we've simplified the equations. And now we'll rearrange the equations in matrix form. So let's go here. So that, I forgot to copy over V1. See, that's the sort of mistakes, the silly mistakes I do. I forget to copy over a negative sign, so on and so forth. So now put it into matrix form. Like this. Now I'm recording after the fact, so I already know that I've said this, but you should get acquainted with your calculator. You could store these numbers as variables, and it will make your life easier into your calculator. Read your calculator's manual. At least you could do that on the 991 ES from Casio. So 0.414 with a phasor angle of 130 degrees. 0.093 with a phasor of 68 degrees. 0.093 with a phasor of 68 degrees. And 0.97 with a phasor of negative 5.10 degrees. The x here is 2.60 with a phasor of 165.6. You're literally just copying down. You're just copying down what you've already solved. And now we do Cramer's rule. So for those who slept through class, let's actually note this down here. So this is voltage 1, and this is voltage 2. So the thing that is solved, the Cramer's rule states that that x1 is equal to, so that's the first item here, is equal to the first determinant over the total determinant. And that x2 is equal to the second determinant over this total determinant. x1 and x2 in this case are v1 and v2. So let's replace that. Okay, what's determinant 1, determinant 2, and total determinant? The total determinant is equal to the determinant of this matrix that we just assembled, this one here. The determinant 1 is a determinant of the same matrix, but with the first column replaced with the solution. So that's x, y. You can see I have annotated the names here. And then keep the second column, or all the other columns, depending on how many columns you have, the same. And then the determinant 2 is equal to the determinant of the matrix. Yes, you replace the second column, not the first one. Now, you already know how to find the determinant of a 2x2 matrix. It's crisscross applesauce. So determinant is equal to AD minus BC. Determinant 1 is equal to XD minus by, and determinant 2 is equal to ay minus xb. We're going to skip the calculations part because that's just a waste of time. We get that total determinant here is 0.389 with a phasor of 125 degrees. Determinant 1 is 2.522 with a phasor of 160.5 degrees. And that's a 1. I can't draw straight. 0.5 degrees. And determinant 2 is 0.242 with a phasor of 53.8 degrees. And now we just plug and chug. That's it. We take this, let's move it to the side. Voltage 1 is 6.48 with a phasor of 35.5. And voltage 2 is 0.622 with a phasor of negative 71.2 degrees. It's all degrees. So, there you go. We have rearranged the equations in matrix form. We showed the steps of Cramer's rule, and we calculated the node voltages. Now we have to do questions 6 and 7. Express I, let me just bring this down. Express I in terms of the node voltages and calculate its numerical answer. Draw a phasor diagram showing VS1 and I phasors. Let me just grab a picture of this because this will help us. So, this is I. Now recall that the current running through a wire is voltage divided by resistance. That's the exact same thing that we did in the nodal analysis. If you remember up here, we said that the current running here, right, from ground up to V1, this is I, right, is 0, our ground, goes through the voltage source to gain 12 with a phasor of 45 volts, minus its destination, V1, and then divided by its resistance, 3 plus 2J. So there you go. I is equal to, we can remove the 0, that's 12 with a phasor of 45 degrees, minus V1 over 3 plus 2J. We know V1. We could substitute it from up here because so V1 is 6.48 with a phasor of 35. 6.48 with a phasor of 35.5 degrees. And if we do the calculations, we get that I is equal to 1.58 with a phasor of 22.1 amps. Let's draw the phasor diagram. So if you've forgotten the phasor diagram, I'm just going to use the tools here because I can't draw for the life of me. Do forgive me. So phasor diagram is basically just a triangle. That's it. That's all it is. It's a triangle where your y component is the imaginary and your x component is the real. So draw a phasor diagram showing V source 1 and I. Let's draw V source 1. That's 12 at an angle of 45 degrees. If you put 12 with a phasor of 45 degrees and you turn it into rect form, you'll find that it is 8.48 along the real and 8.48 along the imaginary. Let's put J there. There you go. So this is 12. So VS1, the absolute value is a magnitude of 12 at an angle of 45 degrees. How about I? I is 1.58 with an angle of 22 degrees. So let's draw that. So this is I. The absolute value of I is 1.58 an angle of 22.1. This here, 22.1 degrees. It's a little cramped. You can draw yours bigger on the test. I won't judge you. So 1.58 with a phasor of 22.1 degrees. So this here is 1.4. Sorry, this is 0.59 J. This here is 1.46. And so this is the phasor diagram. All it is that you are drawing the line with its components and its angle. That's it. So that is the entirety of question 2. Let's cross those out.